Okay, so this is a new table of contents, so we're moving on to section 2.3, which is biconditionals and definitions. Now, what in the world is a biconditional? Well, a biconditional is a single true statement that combines a true conditional and its true converse. So, remember, a conditional is the if-then statement. Usually that's what they give us. And a converse is still an if-then statement. We just switch the hypothesis and the conclusion. Now, remember when we were working Friday that whenever you wrote some of these if-then, some of them ended up true, some of them ended up false. So, in order for you to be able to write a biconditional, both the conditional and the converse have to be true. Now, you can always know it's a biconditional statement because somewhere in that sentence you will see the phrase if and only if. If you see that phrase, you're looking at a biconditional statement. Okay then, so let's look at writing a biconditional. So the directions are asking what is the converse of the following true conditional. So it's telling you, hello, I'm giving you a conditional statement and I'm already telling you it's true. If the converse is also true, rewrite it as a biconditional. Okay, so the statement that we're looking at is if the sum of the measures of two angles is 180, then the two angles are supplementary. Okay, well, that's the conditional. They give it to us. So the first thing we need to do is identify what is the hypothesis and what is the conclusion that we are going to have to switch in order to write the converse. Okay, well, the hypothesis is the sum of the measures of the sum of the measures of two angles is 180, and then your conclusion is the two angles are supplementary. So when we write our converse, we should have if two angles are supplementary, then the sum of the measures of the two angles is 180. So to figure out if we can write a biconditional, we need to figure out is that converse statement true. So let's think about it. If you have two angles that are supplementary, well, what's the definition of supplementary? Two angles that had to be 180. So the sum of the measures of the angles is 280s. That is true because by the definition of supplementary, they had to be 180. So whenever you go to write the biconditional, there are two different ways to do it. So we have already identified the conclusion of our original and the hypothesis of our original. So we're still going to use those two phrases, but instead of writing it in an if-then form, we're just going to use if and only if in the middle. So the first way that you can write it is two angles are supplementary. So that was our conclusion of this one and our hypothesis of this one. Okay, two angles are supplementary if and only if. Well, ding, 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 ding. That's what makes it biconditional. Okay, so if and only if the sum of the measures of the two angles is 180. And that was the hypothesis of this and the conclusion of this. The idea behind a biconditional statement is just no matter which way you read it, so you can read it from beginning to end, and that's going to give you a true sentence, or you can also read it end to beginning, and it's still going to give you a true sentence. Now, in terms of the PQ stuff, I meant to put this with the definition, but I didn't. I'm going to throw this in the top right hand corner. I'll use red up here. Okay, so in terms of the PQ stuff, if P then Q, that was P arrow Q. Well, now we want to write it a way that says, well, you don't have to go from P to Q. You can go either way that you want to. You can go P to Q, or you can go Q to P, and that statement is going to be true. Now, when we read this P if and only if, because, hello, biconditional, if and only if Q. So in order for that P to be true, that Q also has to be true. Alright, now going back down to biconditional, that's the first way that you can write a biconditional statement. The second way that you can write it is just by switching that hypothesis and the conclusion, but still having if and only if. So number 2 would be the sum of the measures of the two angles is 180 if and only if the two angles are supplementary. Now, you don't have to have this word for word. As long as you have the main hypothesis and the main conclusion, you just put, instead of the angles, you put the or they or them. Second, that's fine. As long as you know what you're talking about and you've specified two angles but with one of the statements, then I'm fine with what you write. Okay. Now this is an example 2 for you to try. So pause, do this, and then see if you get it right. Okay, so by now you should have paused this and worked it. If you did not, pause this and work it. Remember, this is like class. If I told you to work this one on your own, you wouldn't just keep listening to me. You would put pencil to paper and try to figure it out. Okay, so if two angles have equal measure, then the angles are congruent. Okay, we know that this is a true statement, so now we're going to write the converse of it. Well, switch hypothesis and conclusion. If two angles are congruent, then the angles have equal measure. Okay, so if two angles are congruent, do we know they have equal measure? Well, yes, we do, because that's the definition of congruent angles. So that means our converse is true. So when we write our biconditional statements, there's two ways you can do it. The first way is two angles have equal measure if and only if the angles are congruent. Or the second way is two angles are congruent if and only if the angles have the same measure. Okay, so that is the end of this video. There will be 3 more, so make sure you're taking good notes and continue to video 2.